So you choose the material. So since we're talking about garbage, let's use garbage. Let's say we use 1 ton of garbage, okay? 1 ton per hour of garbage, which is about 2,200 pounds per hour, okay? And normally if it's, a lot of times the garbage is saturated with water, basically 50%. And if it's too much water, we do not want to pyrolyze it just the way it is, because let's say you start at 80 degrees and you get it to the boiling point, which is 212 degrees. And then basically from here, for it to make steam, so if I want to take it to 1200, which normally we'll take it to 1200 degrees, we have a lot of waste heat in here, that water in for no reason. We have to do that. So what we do is we dry it down to 20% moisture. So when we dry it down to 20% moisture, then it's very, very clean and nice, and we can actually make it go. So let's say it has 20% moisture, and normally garbage about 15% turned into carbon.
Can you use a better ink? Yeah, we can't really see this.
You like green?
Yeah.
How about red? Red. Yeah.
Anything
Writing
stands
soup.
out, that'll be fine.
Okay. Now, if anytime you don't like this color,
I
they said the lady stopped at a stop sign, at a light, and it turned red, and then turned green, turned orange, turned red, and didn't move. The police officer was watching, came back, opened the door, says, "Ma'am, we don't have any other colors." So we have 2,200 pounds. That's mass, right? Total mass. And then we have 20%, which is 440, right? 440, right? 440, which is water. And 15% is what, 330? 330. So if I subtract all of these from 2,200, and I don't have that fast up my brain.
1430?
Yeah, 14 what?
30?
1430 pounds per hour is going to turn into gas. Okay? So if I multiply that by 18, every pound of gas will turn into 18 pounds of 18 cubic foot of gas, each pound. So multiply that by 18, please.
It's a 25,740.
25,740
Uh-huh.
cubic foot, right?
Yeah.
And multiply by 500.
Divided or multiply 500 or 5?
500.
500?
Yeah.
Yeah, it's 12,870,000.
Beautiful. So 12,800,000, forget about the 70, BTU per hour, okay? Per hour. And from this 12,800,000, I use about 2.5 for operation. So use that into it for heating and all this stuff. I end up with approximately 10 million BTU. And if you use a generator, normal generators about maybe 35%, at least 35% efficient. Mm-hmm. So you get about 1.1 megawatt hour of electricity from a ton of garbage. Okay? So now, if this is cheap and you don't want to do electricity, you have other choices. So what we do is majority of this material comes out in the form of hydrocarbons, CH4 or C2H6. So it's normal gases. So we go to a customer and say, what would you like to see? Because garbage doesn't give you a lot of liquid fuel. It give you a lot of, not a lot of, but some aromatics like xylene or toluene, but very little, maybe like 2% or 3%. So what we do is we have a technology that we can reform this. So what we do is in the process of reformation, we do it with steam reformation, and we turn that into carbon monoxide and hydrogen. Okay? Carbon monoxide and hydrogen. Now, carbon monoxide and hydrogen are the mother of everything else, really. So if you now I can have the choices that carbon monoxide plus hydrogen can give me CH3OH. It gives me methanol, and then on the next process I can turn methanol into ethanol. And all carbon monoxide and hydrogen will give me CH2 plus water, H2O. This is called Fischer-Tropsch, FT process. And we can make liquid fuel. We can make a FT liquid fuel, which is this. This is, right now, this is, in the United States of America, it's about $9 a gallon. The US government subsidizes. The reason is because all of it becomes jet fuel. And jet fuel is very expensive. And so, I couldn't find it. the garbage. So, yeah, and so we can make that, or we can make DME, dimethyl ether, which is normally used in Europe as replacement for number 2 diesel. So we can make all sorts of stuff, and also we can make wax out of it. That white wax, if you,
This?
yeah, that wax comes from an FT process. Yeah. And this is food quality wax. And that wax,
Smells like.
yeah,
Oh, yeah.
yeah,
It's
and
wax.
that wax is made from human waste, actually.
Wow.
Yeah.
I don't believe it.
You
So-
smell it again?
I don't
So-
believe it. Would you like to smell it? It smells like oil.
We were trying to develop an ethanol plant
Yeah.
up in Central California.
Yeah.
Because I've got one of the largest stone fruit growers in California.
Yeah.
They have between 3 to 20 tons of waste a day that they get charged a fee to get rid of. So they rather give it to dairy farmers
Yeah.
so that the cows can eat.
Yeah.
Cows are eating peaches
Right.
instead of
No wonder it tastes.
Yes.
yeah.
We don't, I was going to tell you, I forgot. I had a guy from Panama. He came with an inspector to see if the technology works. He made me pyrolyze tomatoes. I didn't think I was gonna get anything out of tomatoes, honestly, because it was all tomatoes. I said it was tomatoes on 90% water,
Right.
But I got gas. I got a flame out of tomatoes. So yes, it's very, very possible to.
Because this is much faster than the ethanol.
Also, you have a lot of option. This way you have tremendous amount of option. So that you don't have with digestion, you have one option, a very little option. But with our technology, I decide what catalyst to use to get what. And
Now, is it beneficial? I have a lot of potential projects, and is it better if it's pre-dried, if there's some separation?
yeah, it's fine. I mean, I normally prefer if you don't have more than 20% moisture in it, so that makes our work easy. Otherwise, we have to put a dryer and dry it to that level.
Okay, because I'm gonna shift over.
In wood, we are having a big project coming up with wood in the central California.
Okay.
I mean, we have excess waste wood. We have 300 years of excess wood in the on the ground, and that's why we get all these flames. And we can turn them into anything you want. We can turn it into alcohol. We can propanol. We can turn it into fuel, liquid fuel. I mean, it's very valuable. We can,
You could even do it,
and the
right?
carbon. And I didn't even you touch the carbon. The carbon, and then that's a completely different. We make graphene. you know, from the carbon. And we have our own technology. It's not like we grind the hell out of the graphene to get 2 milligrams. So I developed a technology that we can make graphene. I made actually batteries that do not quit. Let me show you. I have a battery that Najib John, could you bring that battery that we're testing?
I was gonna ask, do you have any clients that are dispensaries or the growing side of the
Actually, I have 5 growers, cannabis growers.
Okay, that's what, 'cause
Yeah.
Yeah, we have. I have 2 super bags of hemp right in my office, and
Well, one of them's just in Cudahy.
yeah. Well,
So-
see, there you go.
so do you
and-
have any clients that are already doing the marijuana production, and then there's all the byproduct from that?
Yeah.
Do you have anybody that's
Yeah,
doing
I
that?
have a couple of them. Yeah.
Okay, because I was
Yeah,
thinking,
I got this. This one is from Canada. I got 2 super bag of ham from Canada.
okay.
Well, so I'm not supposed to say the name of the company, but we're working with Procter and Gamble
Oh yeah, I know.
on one of their paper.
No, you should have put the. Yeah, okay. Just connect it. Yeah. This we have been testing it now. How long? Do you know?
More than a month now.
Oh, yeah, more than a month, and it charges itself.
It's really low right now, but you can see it's like.
Yeah, yeah, and it never goes below 2. It never goes below 2 volts.
See?
It doesn't go below 2 volts.
So,
Yeah, I'm trying to fail it, and it doesn't fail.
so Procter and Gamble has a paper factory,
Yeah,
and one of my associates, they have a drying technology because Procter and Gamble, and it's in California, they use up a huge amount of water, and you know how valuable water is in
still 2
California.
volts. It just doesn't. Oh, I'm sorry.
So I was saying they use up a huge amount of water.
I have
in
sold
there.
burners to Procter and Gamble. So,
Okay.
So they're my customers.
Okay, so that's one of the biggest problems is they're using up so much water that my friend's company is doing a drying situation. 'Cause I guess they can get it down to like 90-something% dry,
Yeah,
and then Procter and Gamble can then keep reusing the same water.
yeah.
But I don't know what they're doing with that waste product
Yeah.
after they're done because again, it's
What,
yeah,
what,
some
what
kind
is,
of
what is,
powder.
I'm sorry, what is the waste from?
Paper factory.
Oh, yeah. Oh, fantastic. Yeah.
Yeah.
That's that's a nasty waste.
Yeah.
You know.
Because they're already working with them to develop this drying solution.
Yeah.
And I don't know if they have a use for the byproduct afterwards. And again,
Yeah.
it's
And we can turn it into energy then, no problem.
okay, because it's
Yeah.
here in Southern California.
And I have done this before, you know, with the paper waste, not from Procter and Gamble, but other people on that send samples we run tests on the.
No, this is very interesting. Like I said, I've
Yeah.
got
Yeah.
I've got the farmers with the waste. Again, as I said, they get charged
Yeah.
to dump it, so they can't just dump it.
Yeah.
Well, we could charge them too,
And
and then make electricity.
well, and literally, they're giving it away to dairy farmers so that they don't have to get charged a tipping fee. And if you can turn it into something that the farmers can use, either
But energy is very, very, you know, I mean, California is expensive.
yeah.
You know, electricity is very expensive. My bill is $900 a month. I don't know about yours, but
Hawaii is crazy.
yeah.
I pay 35 down in Florida.
You
We
have
got solar power,
And a
batteries.
Yeah.
Yeah.
and that's only for the hookup fee to be.
Yeah, we're pretty much just paying the hookup fee every month.
That's good.
Yeah.
No, there's and you said you're
We have
in-
solars here.
Do you?
Yeah.
How big?
I don't know how big it is, but I used to pay like $3,000 a
Yeah.
month. Now we pay like maybe $80.
Yeah.
So,
So you know,
Yeah.
big big
You are
difference.
certified.
Yeah, I'm N-Phase certified, Generac and other stuff I've done.
So that's where I've been making my money over the last few years is installing solar.
Maybe I should talk to you about my house.
Yeah.
How about Mosaic? Are you working with Mosaic?
I did one project in Italy,
Okay.
and they were making mosaics, and they were making it from wine glasses.
Oh,
Yeah, so they were breaking the wine bottles, not wine glasses, wine
Okay.
bottles, and they were breaking the bottles,
uh-huh.
but they would end up with these corks, the top of
Oh.
the plastic and corks. And so what I did was I supplied them a unit that we would pyrolyze all of those mountains of them. So they had a mountain. I mean,
Oh,
they
Sure.
had,
yeah.
and we sold them a pyrolysis, and they just produced energy because also they needed a steam boiler. They had a steam boiler,
Okay.
so we utilized the gas for the steam boiler, some generation of electricity.
Yeah, and I was talking about Mosaic, the company that broke off from Cargill, the phosphate and the potash mining.
Yeah.
Are you familiar
No,
with
no,
that?
no,
Yeah.
no.
So they're environmentally
Yeah.
not-
Are they? Is the waste water waste or soil waste?
that's why I need to do some
Yeah.
research. But
If it's
they're-
water, we can handle it.
Okay.
You know, if it's soil, it's probably what we can do is run it like you do soil cleanup,
Yep.
and we can separate. But mostly the water is very easy to handle.
So tell us about the carbon.
Well, the only carbon to my mind is that is from tires is $1 a pound. It's because we get carbon black from tires, and tires will give you 37% carbon black. So the carbon black is a big source of income. And what I did was I take that carbon, and I have a process that I dreamt up, and it worked. And what I do, I break up the structure of that, and then you can actually turn it into dust with your hand. And any carbon, you can break it up with your hand, with your finger. And we have been producing graphene, and some of these stuff that I built is from our graphene. These batteries.
Okay.
We utilize those for developing, batteries. And this is not, he said 1 month. I've had this for like 7 weeks now, and they're still not going down. It's just we don't even charge it. So
I'm just blown away. I'm like, why are we sitting in a 50-story tower building right now, and why aren't you on the New York Stock Exchange?
well.
This is amazing technology. It's
I'm
just-
I'm getting too old to be on the New York Stock Exchange. But at the same time that I'm satisfied that we are doing something good to the world. At the same time, I'm kind of satisfied
Yeah.
with what we do.
Yeah.
So
Where's your nearest facility?
we have a test unit here. The problem is that we have a facility downtown Los Angeles, but he will not let anybody in. So if you run it's called Cornelius. Yeah. Core infrastructure.
KOR.
Yeah, KORE actually, infrastructure, and they have a site, and they have been running for 4 years now, and they're working with the gas company, and also working with the South Coast Air Quality Management District. South Coast Air Quality gave $3 million to them, so working with them. But I tried to take, in the past, some customers there, and he would not allow people there. But we have a test unit, we can test stuff here. It's just unimaginable how many spam calls I get every day.
Oh yeah, never ends.
It's just like, it's just
Never ends.
Okay.
So do you have like a presentation PowerPoint or
Yeah,
something.
yeah.
Yeah, 'cause that's what I'm gonna need when I
Hey,
do.
Jim John, can you come play some of the
Most recent
propaganda?
one. Yeah. I have the last propaganda one.
Yeah,
Most recent one.
yeah.
And over here, you said that hydrogen is a byproduct also.
Yes, yes.
So can you create hydrogen fuel cells
Yeah.
from that?
Yeah, we produce a lot of hydrogen. I break up into hydrogen and we can produce tons of hydrogen. I have another technology that also we can produce hydrogen from natural gas. We can produce low carbon hydrocarbons. For example, C5 to C14. Which is basically more of a jet fuel in gasoline, and a lot of hydrogen, and you don't have to really do. It's called electron beam. We just do it with electron beam. But other than that, we reform and have built so many reformers. We can reform the gas and we can produce hydrogen, as much hydrogen we want. And we don't have to go because it's in order to produce if you want to produce a liquid fuel after that, I normally go to CO, carbon monoxide. So this requires high temperature. So we have to go to like 1,600 degrees Fahrenheit. But there's a competition between CO and CO2. The CO2 is produced at lower temperatures. So basically we stay at 1,200 and below degrees, and then for the same process you can produce hydrogen and carbon dioxide. And carbon dioxide we normally don't want to put in the environment. We turn it into ice.
Okay.
So the ice is at about $7 a pound. So it becomes a good byproduct. But yeah, we can produce hydrogen.
Well, no, I mean, I don't even have to leave California. I live in San Clemente,
There you go.
so.
You live in San Clemente. You're right here.
Yes.
Yeah. See my neighbor. I live in Corre de Casa.
Oh, okay.
Yeah.
Well, technically, I'm on like the border of San Clemente. It's Ladera Ranch,
Uh-huh.
but no one ever knows where Ladera Ranch is.
I don't
so.
care how far you go. You're my neighbor.
Yeah. So what? I wish I had my son here. My son is organic chemist or
Chemical engineer.
Well, no.
Oh,
No.
organic chemist.
No, he works in the pharmaceutical industry.
Oh,
I-
okay,
I keep saying
okay.
this is much better.
Yeah.
Yeah.
But I keep learning that chemistry is so specialized.
Right. Yes.
He's making cancer drugs.
Yeah.
So
Well,
I said this is
I
more
see he's
interesting.
smarter than me.
Oh, I don't know about that. No, just like I said, I'm working with groups up in Central California, and I said we ran into a problem with a company that wanted to make the ethanol, and here's one thing that you might keep in mind. I have funding for any type of product, because you have a track record. Any public like city that wants to do it, I can fund it. Any of your technology, I have the funding for that.
Oh, I have so many people who love you.
Yeah, I can fund this.
Yeah.
Because
That's
one
the
of the
biggest-
biggest problems is companies don't have a track record in these fields. They go, oh, we've been in business 2 years. Well, my funder, they want to stay involved with the city for 100 years. So they do the mush market, municipalities, universities, schools, and hospitals. And they do it as sustainability as a service. So it's not on your books as debt. It's a usage fee that you pay.
Yeah.
But you don't. They don't benefit from sharing in the income. You just pay, a usage fee every month.
Yeah.
And so cities don't have to float bonds. They don't have to do anything else.
That's beautiful.
They can. And this company, because you have a track record.
I
they'll fund.
have actually guys here who come here all the time, and maybe I should introduce because also we have a plastic problem here. You know, we have like 10,000 or so tons of plastic a month here in California, that we could turn it all into very, very good quality fuel, beautiful fuel.
Well, and the plastic recycling's pretty much failed.
Yeah.
Only like 5% of it ever gets
Yeah.
recycled.
Yeah, and so, I mean,
Goes to the-
and not only that, but it becomes a huge profit center. You know, the equipment and all that will pay off in 1 year or even less, you know.
Well, what's interesting too is the synergies, because one of my good friends is working with Republic Waste. And he does his technology is actually tracking how, like, where their trucks are at all times, and they actually track garbage bins, how full they are.
Yeah.
And that's all that they do right now. But he's like this with the CEO of Republic, because he's solving all of their problems.
Yeah, no, so many people that we have, you have, that would be dying to get introduced to. So, and these are really not something that we claim. This is something I can show them. You know,
Right.
we can run a test. We can on one of the units, and we can actually say this much went in, this much went in, and this much gas, and look at the gas, and we run and turn the generator on. I mean, that's how I do it. Put a generator, because seeing is believing. You know,
Yeah.
when you turn the generator and it turns on and it's giving you electricity from that banana peel that you just put into the unit, you know, that's impressive. You know,
Yeah.
people like to see that, and we do that, and we can do that. And I have at least 2 groups of people who are working locally in here, and they're targeting tire and plastic, but they can target anything, really, any waste extreme, doesn't matter. They will do the work
Yeah.
if they get funded.
Well, the funding, they want public entities.
Yeah.
So if you can form a public-private partnership,
Uh-huh.
they'll fund it. In other words, even if the city owns the land and leases it to this company, and the city will sign
Yeah.
for it, they'll fund it.
So
And
that's,
there's the minimum dollar amount is $1 million. There's no upper limit. They can do 3 billion.
wow,
if they
that's
need to.
fantastic. This guy, because he couldn't find any here, he found a coalition with Illinois, with the government of Illinois, and they would give him the property. Also, they will, like, 10 years of tax, no tax or something. You know,
Well, if we can find a
Yeah.
way to structure it so that Illinois will sign,
yeah,
They'll
already
do
s- yeah. Oh yeah.
yeah.
Let me talk to him, okay?
Okay.
And introduce him, and then we can have a meeting and.
Because right now we're working on a reclaimed coal factory in Ohio.
Yeah.
And again, it's complicated, but we're structuring it.
I wrote
Uh-huh.
10 letters to John Kerry, the czar of.
He's too busy flying around.
10 letters, and I told him that I know you guys are shutting down the coal, but I can turn
Yeah.
coal into natural gas, and then you can, you know, I mean, we have all this like wealth of energy that we say, well, don't burn it because it'll kill people, but it because you don't know how to burn it. But if you give this technology a chance, I'm gonna put the coal in there and turn it into, you know, diesel, jet fuel, whatever you want, and also turn it into gas and gas into electricity. Sky's the limit. Not one got answered. Nothing.
Yep.
I think it just went in there and just and I give up.
I hate to say how corrupt they are, but
Yeah.
they're pretty
Well,
corrupt.
don't hate to see, just say. Yeah, no. I mean, when they come on TV, they talk so big. This is from Los Angeles sanitation material that we had a project 5 years.
Can you also email that to me?
A portion of the biosolids is trucked to this landfill for disposal. It's the biggest landfill in the country and is only 2 years away from closing its doors. Decline in landfill capacity for biosolids disposal is a trend seen in many parts of the world.
That's it.
What is
This
that?
wastewater
Just say
treatment
no.
facility also directs some of its biosolids to land application sites. Disposal of biosolids in urban communities has meant increased resistance, and many treatment facilities resort to traveling long distances to remote application sites. Current methods of dealing with biosolids are effective, but expensive, and create a substantial carbon footprint. Trucking biosolids is costly, burning a great deal of fossil fuel. When placed in landfills or on land application sites, biosolids may release methane, a potent greenhouse gas driving climate change. These current methods are used at wastewater facilities worldwide, and all of these facilities face the same challenge of finding a long-term solution that is more sustainable and affordable. There's a better solution to biosolids
core.
management, created by a group of scientists and engineers at Core Infrastructure.
I actually
Core
own
Infrastructure's
like
patented process
33% of
turns
core which I sold
biosolids into this.
back, but
High-cetane, ultra-low sulfur diesel fuel. It accomplishes this transformation on site while achieving a carbon-neutral footprint. The Core Infrastructure process offers a clean alternative to current biosolids management, eases the strain on our ever-shrinking disposal sites, and creates a superior clean-burning fuel from an abundant, renewable resource. This isn't just a concept. It's already become a reality. Our permitted, patented process has been running for over 2 years at our demonstration site, located at a major wastewater treatment facility in California. The Core Infrastructure process is a closed system consisting of 2 subsystems. The first stage is called pyrolysis. Pyrolysis is a process of thermal degradation of organic matter using high heat in the absence of oxygen. The biosolids enter the system through a series of airlocks, which ensure a vacuum is maintained. During this phase, a pyrogas is created. The gas is then cleaned, removing all particles and heavy metals, ensuring that the gas is free of contaminants. The pyrogas created during pyrolysis is not only used for the production of fuel, it also powers the Core Infrastructure process itself, requiring no outside energy. The primary byproducts of pyrolysis are carbon char and water. The carbon char is benign, containing 0 PCBs and no dioxins, and can be recycled for a variety of commercial purposes. The water is returned to the treatment facility and meets all requirements for discharge. The second part of the system is called liquefaction. During liquefaction, the pyrogas is preconditioned by removing hydrogen sulfide and carbon dioxide. It's then reformed with steam in the presence of a catalyst into a synthesis gas. The final step transforms the synthesis gas into a liquid fuel by recombining the carbon and hydrogen into long-chain hydrocarbons. The end product? A high-cetane, low-emission diesel fuel. The Core Infrastructure process has several important features. It's a closed system that operates around the clock and creates no discernible odor. CO2 from the process is not emitted, but is captured and beneficially reused. The process reduces biosolids moving off the facility by nearly 90%. Importantly, the Core Infrastructure process meets all emissions requirements of the South Coast Air Quality Management District, a regulatory agency among the strictest in the world. The Core Infrastructure process can handle biosolids of varying degrees of treatment and water content. In developing countries where wastewater treatment facilities may not include stabilization and dewatering equipment, the Core Infrastructure solution provides an alternative that is beneficial to the environment while also solving health and safety challenges of untreated sludge. The Core Infrastructure process is modular, easily scalable, and fits within a small footprint. The system is designed to be implemented on a small or large scale. That means the Core Infrastructure process can be rapidly deployed with minimum disruption to existing infrastructure, while
How
having an
much of the
immediate
process
positive
is
impact
yours
on a
and how much is
facility's solids
Core's?
handling capability.
all of it is
The
mine.
Core Infrastructure solution can then be expanded by
So,
adding more modules
we don't
at a
need
rate of
Core
growth
to
that
do
works
it.
for
You don't need
facility
Core at all.
specific needs.
Because
The Core
I'm the
Infrastructure
patent holder.
process is a technology that delivers solutions. It mitigates the need and reduces the cost of off-site biosolids disposal. It lessens the greenhouse gas emissions associated with biosolids management. and creates a renewable, domestically
we're-
produced, superior
like,
clean fuel
let's
source
say peaches
that
and
can be
apples,
inserted
apricot.
directly into the existing supply chain.
Is
The end
diesel a
result,
byproduct?
cleaner
Can
air
diesel be a
Can be.
byproduct?
and cleaner fuel.
Because it has
The
sugar.
core infrastructure process, a future solution
Is fertilizer
that's
another
working
byproduct?
today.
Yeah. The carbon has phosphate, so it's
Natural.
beautiful natural fertilizer.